Hello, everyone, and welcome to the Advanced Alteryx Spatial and Predictive Data Conference session. It's presented by Matt Heinze, Customer Success Manager, and Connor Kelleher, Solutions Engineer. We're going to start off with a quick little poll when they start talking, but other than that, just get ready to learn. Gentlemen, take it away.
Thanks, Travis. As Travis said, my name is Matt Heinze. I am the Customer Success Manager at Alteryx supporting ASU. My ambition in life is to help you slay your data monsters. So whether it's today with some of what you learn in Connor and my class here, or whether it's during office hours or a session you want to set up with me, feel free at any point to reach out and we'll be happy to help you through the challenges you're having slaying your data. The quick poll that Travis mentioned, just trying to get an understanding of what people are familiar with in terms of the content we're going to talk about today. So maybe you could put that up, Travis, and we can get some, there we go, thank you. And we'll just get an idea of people's familiarity with our spatial capabilities as well as some of the predictive capabilities. So if you don't mind filling that out, that would be great. So as you're filling that out, just to let you know, today we'll really focus about half of the time looking at the spatial capabilities within Alteryx, and I'll lead that part of the session. And then the second half, we'll look at some of the predictive modeling capabilities. And Connor, my colleague Connor, will handle that part of the session. So that would be, that'll be the plan for today. Just gonna let a few more of these roll in. So nobody's using spatial yet. Some folks who maybe could use it. And then not too many in terms of R Python, but a few folks in terms of models. Perfect. So as you're still filling that out, I'll just jump ahead. For those of you who aren't already members of our community, Alteryx users, please, I would suggest taking a look, signing up to be part of the community. So much great information out there in the areas of spatial and predictive, but really in all areas of what you can do with the Alteryx platform. So I'd certainly encourage you to go out to community.alteryx.com. In addition to sharing knowledge with others and asking questions, the Alteryx Academy is housed within the community, a great source for other videos, other learning sessions that will advance your knowledge on the platform as well. So with that, we'll jump into this introduction to spatial. Just taking a quick look at the final poll, it looks like no one on the call has used spatial building blocks before. So this will be new to everyone from the sounds of it. Looks like there are some of the team that have the possibility of using it. So hopefully this will inform how you might think about using the spatial capabilities. And then in terms of the R, Python, and classification models, or sorry, the modeling, I will leave those for Connor to talk to you about in the second half. So first I want to start with the agenda, just a quick introduction, particularly to spatial. And then we will get into the spatial building blocks, and then I'll walk through an example using some applicant data that hopefully hits home a little bit, but something Connor and I put together, and hopefully it'll follow for all of you. So just to give you a little bit of history, and I like to do this only because people don't necessarily realize, like yourselves, if you haven't used the spatial components, that this is really a part of Alteryx's legacy. We were doing spatial analytics back in 2009, and you'll see there a couple of different press releases and comments around how important spatial was to a company at the time called SRC, that now is called Alteryx. And the spatial piece was just a component of the package, but obviously Alteryx now in and of itself has become a major success. And we're known to be the leading platform for self-service data analytics, whether that's the prep and blend and analysis that you might have seen yesterday if you joined the beginner session, but it's also sharing and deploying at scale, and really getting to insights quickly. And that's, the most important for probably everybody on the phone, is how can we quickly get there? But before that, Alteryx was one in a suite of other products really focused on geographic business intelligence. And so the origin of the name really is all about altering YX being latitude and longitude when you're in a spatial world. So everything from the name of the company starts with that spatial capability. So let's talk a little bit about spatial data. Why spatial analysis, right? So you might have some different questions that you want answers to. How far do perishable products, for example, in the consumer goods world, need to travel to get from a DC to a store? How many uninsured flood victims, flood customers live within 10 miles of a storm surge? Or, what is spatial data, right? It's data that has some type of graphical component allowing for visual representation and allows you to do additional spatial processing. And in particular, those might be measuring distance, driving times, creating custom boundaries or what you might call polygons. And then in Alteryx, spatial data is defined by a spatial object field in the data stream. And so obviously we'll spend a fair bit of time looking at spatial objects today. So just to give you a flavor for what that looks like in the application itself. So hopefully everybody's familiar with the look and feel of the results grid here. So on the left, we just have a result with some customer information and store numbers. And then on the right, we've got those same customers and store information, but you'll see on the very right side, there's this new field, the additional field called centroid. And this happens to be a point centroid, a point on a map. And so that centroid concept is a spatial field within Alteryx. And as you see there, just a note, as you start to think about working and start working with the spatial data, is that if you want to view a spatial field, it will not appear in the results grid the way a traditional piece of data like a string or a number would appear. It actually needs a browse tool to actually browse and view the map that results from adding that spatial field. So how about spatial data types? There's really three. So point data types, like we saw in the last screen. So this might be a house, might be a store location, might be an apartment building for students. It might be your campus main location. Any of the buildings on campus would each have individual points. A line might be a street, some sort of route, or a river, for example. And then when you get into polygons, it might be an arbitrary polygon, which is kind of what we'll do today. We'll build one out. Could be zip codes, the boundaries of a zip code, or a county or a state. And then it could also be what we call a trading area, which is like a radius or a drive time around a given point. So how those kind of get visually represented as well. So let me bring up the chat and make sure there's no questions. Travis, anything coming through where folks have questions? No questions. I'm not seeing the chat actually, Travis. Oh, here we go.
Got it.
Thank you. Got it now. Thank you.
Mm.
Okay. So yeah, as I don't think I mentioned earlier, feel free if there's something that comes up as I'm talking, drop a question in the chat or unmute yourself and ask a question, but happy to kind of take those as we go if there are questions that people have. So the spatial building blocks within Alteryx. So there is a green toolbar within Alteryx that is indicated as spatial. And all of the spatial building blocks have this green centroid appearing design to them. And the first one we'll talk about is create points. most often kind of the easiest one for people to think about and easiest one for me to think about. And this basically creates a point spatial object. It uses a longitude and latitude, call it X and Y field within your data set. The field names can vary. You're going to select which field in your incoming data set is the latitude and which is the longitude. And then the outgoing stream will have a new field that's called centroid. And each of them, as we looked at in the earlier example, will have a centroid field associated. So here's a little example in the bottom with X and Y fields. And then here's your centroid. And in this simple example here on the right, I just plotted one of the addresses of the buildings there on the ASU campus and plotted it in a browse tool in Alteryx. So that's kind of the first, most straightforward one. The call that I would make is this is a nice simple example with a single point in it. Obviously, if you have a data set with dozens or hundreds of records like we're going to see in our example today, then you're going to end up with a browse that has points dropped all over it. And that's what you'll see in kind of any browse scenario. The formula tool. So this is not a green tool. It is not out of the spatial environment, but the formula tool can do almost anything that kind of all the other tools do. And in this case, there are formulas that can be used in the formula tool for things like creating a point. So if you want to be if you're more comfortable with some of the formulas and want to kind of know how things are built, then you might want to use the create point or other related spatial functions within the formula tool. Find nearest. So as we just think about some of the use cases, you might want to find the nearest store, the nearest campus building, whatever it may be to a given point, be that a customer or a student, as the case may be. And so find nearest finds the closest points or polygons in one data stream and the points in a second. Can, as indicated, use it for stores, buildings, etc. And then you might have a target and a universe where you're finding the nearest spatial objects. And find nearest has basically two outputs, which ones match the criteria that you set within the tool and which ones did not. Distance, so we'll use this one today. It's probably most straightforward to think about. What's the distance between A and B? Between a point and either another point or a line or a polygon. And you see a couple of examples here on the right. So it might be direct from one point to another point. It might be from a point to the edge of a line or a polygon, or it could be a drive distance or a drive time. Now, those capabilities for drive distance and time are part of the Alteryx environment, but the drive time calculations in particular and the drive distance are part of a third-party add-on that's available from Alteryx. Trading areas, think of this probably most easily in terms of stores and how far they think people are willing to go to get to a given store. So you can define radii, donuts, or drive time polygons around a given object. So in this case, it might be the radius around the store. They might say people are willing to go 5 miles, be that physical 5 miles or drive time. You can have overlapping polygons, or you can create donuts like you see there on the bottom right by kind of separating your distances. And the drive time polygon, similar to the drive times, would be applicable with our third-party upgrade. Polybuild, so we'll look at this. This is building a spatial object out of spatial points. So we could build a sequenced polygon that might be like a driving route. You can build a sequence the polyline is a route. The polygon is a closed-in object, and then a convex hull is another type of polygon that we'll look at today. You have the option to group fields into separate polygons, and you have the option to sequence your data for sorting and drawing that poly object. So if you have a certain route that your trucks need to go, for example, to deliver goods around the campus buildings, you could do that in Alteryx and specify the route order, and that would build out the route in Alteryx. Spatial info. So this one is kind of interesting because whether it's a line you've been given or a line you've created, whether it's a spatial polygon or a point, there's a number of pieces of information that are stored with that object. And so the spatial info tool extracts that information out of the spatial objects. Things like areas of a given polygon, the type of object, the number of pieces in that parts in that object or points, the latitude and longitude coordinates, its length, and the one we're going to look at today is actually the centroid of a polygon, which is basically, I think of it in simple terms as the middle. Folks with spatial knowledge would be much more specific about the definition of the centroid, but we'll consider it the middle for our exercise today. So before I jump into the use case and into Alteryx, are there any questions?
Looks like we have one from Dan. Does the length field report perimeter of polygons?
I believe you would end up, Dan, if I'm not mistaken, using one of these bounding rectangles and probably grabbing the length of that. But Dan, if that's something that is of interest, I could certainly take a note. Connor, maybe you could take a note and we can follow up with Dan on the perimeter of a polygon.
Yeah, bounding rectangles is different for some of the purposes that I would use. The perimeter, combining that with the area, allows you to define the compactness of a polygon. So that's why I'm interested in that.
Sure. Connor, if you could take a note, then we can follow up with Dan on that for sure.
Yeah.
Thanks. Any other questions? Okay, so the use case that we put together for our discussion today is that we have data on students who've made applications to a school. We want to arrange for those applications to visit campus based on their proximity to one another. Now, not a great COVID example, my apologies, not as many campus visits going on, but nonetheless, we'll divide this group up based on their proximity. So the goal is to learn how to convert latitude and longitude for the applicant's home to spatial points. We will build equally sized groups of applicants to visit the campus. We'll create those groups based on their proximity. And then we're going to share a report showing the groups of applicants and the number of applicants from each state or county that applied by college. So we're going to start with something that looks like this. So we've got an individual ID number, their X and Y coordinates for their location, which college, which state and county and zip code and so on that they live at. And we're going to end up with something that looks like this, which maps out. This happens to be the first group of students that got tied together for their campus visit, and then a little bit of information on the makeup of that population. So with that, let's jump in. So for anyone who was on the beginner class yesterday, you might recognize the first few steps here of the workflow we've got. We're starting with some student information. So this will look very similar to what was on the PowerPoint there. So the ID, the zip code, and so forth. And basically we're just doing some basic prep, doing some date conversion, figuring out the discipline for these students, and then getting it set up so that we can see where they live, etc. And we can start building out our analysis of how we should group them together. So first and foremost, that first step is to jump into the spatial and understand on a map where these people actually are located. So As I indicated, and if you haven't used it before, kind of almost smack dab in the middle of the default toolbar, tool palette at the top is the spatial palette. And when we go in there, we've got the tools we talked about during the presentation and a few more. We're going to start here on the almost on the far left with create points. So create points, we just drag it on like any other tool, and we will connect it to our select. And so the select tool will by default grab a latitude and longitude field if you have them named as such. We do not. So we'll go in and indicate that our longitude is X, our latitude is Y. And then you could get into some more detail in terms of the structure of your latitude, longitude, but for the most part, they're going to come in as floating point numbers, and you'll be ready to go. And really, it's as simple as that. Give it a latitude and longitude, and you'll be off and running. So we'll just hit go. Before we hit go, I don't know if you remembered in the presentation, I said you need a browse tool to look at the spatial objects. So let's go ahead and grab a browse and just connect to that so that we can look at all these locations, points once we've generated them.
Really quick, Matt, I got a
Sure.
question. How do you generate the box around the select section?
Oh, sure. I'll come back to that in just a moment. Let's just take a quick look at the results from our create points. So we, again, X and Y to generate our points. And if I scroll to the right in the window now, the results grid, on the far right, I have that centroid. And each of these are points that are now available when I click on the browse tool. And you'll see now all those points for all those different applicants rendering. And if I click on a given row, it'll highlight the person, but picking them out of all these points is a little bit challenging, especially I'm sure over Zoom. So I think, yeah, I think Laura's already, or Gustavo is already on it here in terms of creating the container, we call these. But if you select the tools you want in your container, you can right click, choose add to a new container, and then you actually control all the colors and so on through the container configuration here on the left. So yeah, if you want to put boxes around them. The other option there, just momentary sidetrack under documentation, is to use a comment as well. And that doesn't actually hold things, but it lets you make a note to yourself or document your workflow. So as you're thinking about documenting and organizing your workflow, those are a couple of great options. So I am going to remove this, delete container only. Just keep in my flow, my mental flow, so I don't lose my spot. So, so now we've got our points where all of our applicants reside. And so now we want to start to think about, okay, the total area that kind of encompasses all of them. You see, they go from kind of this Baltimore area all the way down here to Atlanta and Charleston. So let's think about how we kind of encompass all those folks. And if you remember from the presentation, there was a tool called polybuild. And so we're going to build a polygon now. So we're going to drag that on here to the canvas. Again, same as all other Alteryx tools, just drag and drop. We'll connect our create points tool up to that. And now we've got the option of creating a couple of different types of polygons. So we could create a convex hull, which is what we're going to do here. Or we could create a sequence polygon or a sequence polyline. We're going to go with the convex hull. We have really only one data field, spatial data field we could use at this point, so we're going to use that. And then we could group, like if you wanted to group by state or something, to actually build polygons within each state. In this case, we're going to stick with one polygon to kind of encapsulate, enclose all of our applicants. If you're not so comfortable with, in particular, like what these different build methods are, certainly you could hit the help here, and this will take you out to the help documentation on alteryx.com and go into a little bit more detail on a convex hull versus a sequence polygon and so on and so forth. The other thing you can always do if you have a relatively small data set like this one is just hit go and hit run and see what happens. So would encourage you to do either of those. In our case, we've just got our one centroid, and we're going to build those all into a convex hull. So let's again add our browse tool so we can see our convex hull once it's built. So this will take a second to render. So now there's our convex hull encompassing all of the applicants that we've received to date. And so as we start to think about how to relate these, the way I thought about it, and I'm not an application administrator or someone who designs campus tours, but what we decided was to really organize people based on how close they were to the center of this polygon. So how do we find that center, right? That was kind of the last tool we talked about there, spatial info. We can use spatial info to give us the centroid of our spatial object, which is relatively the center of it. And again, we can add a browse tool to that. Now, for the purposes of demonstration, what I'm going to do is also choose the area just to give us an idea of kind of some traditional metrics that you might want to see out of a given polygon, right? So here we can now see we've got the original polygon and we've got the point, which is the center of the polygon, and we can see that it's got 132,000 odd square mile area. And when we click on the browse tool, you'll see in addition to the polygon, you should now see almost on top of the word North Carolina there, blue dot for its centroid, its center. So any questions on kind of those couple of straightforward tools so far? Okay, so now we've got all these students, all these applicants, and we've got kind of the midpoint of all their locations. So now we want to start grouping them by how far they are from that center point. So kind of the first thing we got to do is bring these data streams back together. And so under the join toolbar, we have an append fields tool. So we're going to take all of that student data, and to that student data, we are going to append the data on the polygon and its centroid. So now you'll see here on the left, we've got the X and Y coordinates and the information on the students. And then here we've added the spatial object, which is the polygon. And you'll see we've now got two centroids, right? We've got one that is the applicant's location, and we've got one that's the center. So I'm going to call this my apologies. Polygon centroid, just so that source centroid seems, you have to know which parts of the append tool you put them on. So I'm going to just make something a little more obvious so that we can continue here. And now when I run this, we will see for each of our applicant records, as we scroll to the right, we've got their original location centroid, as well as the polygon and that centroid of the polygon, along with the area. So now we're ready to start thinking about distance. And so we go back to our spatial toolbar, and we can use the distance tool. So now the distance tool will basically ask us what our starting and destination are. So we're going to use the original centroid, each applicant's location, and then our destination will be the polygon centroid, that middle of their kind of combined locations. And we're going to output the distance. And if we were in a scenario where we were trying to connect to a polygon or find the distance to a polygon, we would have some options here in terms of whether the distance would be 0 or non-zero, depending on what we were trying to find out with that distance. We also have the ability here to use drive time. As I indicated, this is something that's enabled if you have our data package on top of the traditional Alteryx license. And then you can output the direction and the direction in degrees. So we'll just stick with the kind of the standard outputs here in terms of the distance and the cardinal direction for each. So again, each applicant's direction and distance to the center of their collective area. And again, it's a spatial object. So we will add a browse just in case we want to look at any of those centroids. But in reality, the distance tool is not going to output any new centroids. It is going to give us 2 new fields at the end for the distance in miles for the given applicant and the direction they are from that center of the polygon. So now we've got that distance. Now we want to think about bucketing those students, those applicants, based on their distance. So maybe some of the folks who are already Alteryx savvy, do you have any suggestions on what tool we might use to actually take those distances and bucket them into different groups based on the composition of the data? This is a bit of a tough one. I don't use this. Aha, Katie is all over it. Thank you, Katie. The tile tool is exactly where I was headed. For those who aren't familiar, in the prep toolbar, a lot of tools you're probably familiar with: filter, data cleanse, and formula, and select. But here, almost all the way to the right, is the tile tool, which is super helpful in these types of scenarios. We're just going to drag that on the canvas here. And what the tile tool does is it groups data sets. So this is kind of not within what I would call the traditional spatial tools by any means, but it is a great tool for grouping the way we're thinking about here. And so you have a number of different tile methods, equal sum, depending on how your data is. We're just going to choose and be simple and say we want the same number of records in each tile. So each tile is a group of, in this case, applicants. And so the number of tiles, we're just going to use 5 tiles, so 5 groups of students for this tour groups. You can choose not to split on a given column. We're just kind of leave that alone. But really what we want to sort on here is we want to sort on the distance. So we want people closer to be together and further away to be together. And you have the opportunity to group if you wanted to do so, but we'll just leave without any groups today. So we're just going to have 5 groups of students. They're going to be based on their distance from the middle of our environment here. And so now we've got some new fields here on the right that are the tile number, so 1 through 5. And then the sequence. And so what you'll see here is as our distance goes down, our sequence numbers are going to go up to the point where we get to a couple hundred, because we've got 1,000 or so users or applicants. When we get to the 240 range here, 1/5 of our applicants, then we start a new tile and continue on and so forth until we get down. So we've just sorted it and assigned a tile and a tile sequence to each of the users. So if you haven't used tile before, good one to have in your back pocket if you need to break up objects, break up things into groups in Alteryx. So then we want to do a little bit of a report out now. We've got these groups of, call it a couple hundred students, a couple of hundred applicants, and we want to put them together. So another tool that's what I would consider a spatial tool, but not in the spatial toolbar, is the report map. And so what we're going to do is actually put together that little map. And when we do that, we're basically going to go in and configure our data. So from the incoming data set 1, we're just going to actually map those locations. So those are our centroids, and we are going to group them based on tile. So instead of having just one view of all of them, we're going to have all 5 separate centroids. And then just to kind of share with you how some of the visual capabilities of the report map work, we're going to set up the theme. And so the theme is basically what defines the color of those different dots. So I'm going to go ahead and choose the distance as the theme for how you see these objects. And so let's just put a browse tool after this, and we'll take a quick look at what a report map looks like. There we go. And so now you can see each of the groups has its own map of where they're physically located. Now, based on the time we've got, I'm going to be cautious here and make sure that I'm not running over mine too much. So I'm just going to show you kind of one last step in terms of the reporting, and that is outputting. So if you haven't used reporting before, the last step for reporting, unlike data where you would use an output tool, here we're going to use the render tool. And the render tool will let us output to a PDF or Word document, whatever it might be. I'm going to output to a PDF. Here we go. We call this groups, and I'm going to group the data into separate reports based on the group. And I'm just going to append that group to the file name so that we have all of our groups set up. If you did a bunch of headers and things like that, additional information, you could configure those as well. But for the sake of time, we'll just give you an example here. So here we've got now our 5 different maps. And so here's our first group, and you see they're kind of configured widely around our center point here for the student bodies or applicant bodies. So you could continue obviously through each of our different groups. But hopefully that gave you a good starting point in terms of thinking about creating points and polygons and relating them with distances so that you can think about how these apply for those of you who have possible use cases around spatial. So let me just pause for 1 second before we turn it over to Connor and see if anybody had any questions on the spatial side of the house. Happy to help, Gustavo. That's great. Color density maps. That's a good question, Alicia. I'm not familiar with color density maps. I kind of have the cursory level of knowledge, but Connor, is that one you could jump in on at all? Or we could certainly follow up with Alicia as well.
Yeah, one thing to kind of control that, if you go to the report map,
sure,
Matt. So when you report this, you can actually kind of do color based off of some type of sequence. So if you go to the data layer, the data tab, I'm sorry.
Mm-hmm.
and then click on number 1. All right, so you have a thematic map here that we did distance in miles on, and that's going to specify the color of, the point on the map. Now, granted, if you wanted to do that for the spatial trade area, you could as well, and then you could put your density number into this thematic field to get that color.
Yeah. Good. Thank you.
Mm-hmm.
And Alicia, that's a topic where if that's something of interest and you'd like to follow up, just reach out to myself or someone on the Ask the analytics team, and we can get connected for a working session or office hours. Dan, vary the point size based on the value. I want to say that you can. Let me. You can do a custom point. I'm not sure that. Yeah, Connor, I think the points are pretty standard.
Yeah, you
change
did if
all
you
the
go
points.
to style there.
Okay.
Oh, sorry. If you go, yeah, on style, there's a size there to use default on the point itself. You can change that, but it's not dynamic necessarily. One thing that you could potentially do is create a macro to make that dynamic, though, to adjust the XML on that.
Well, what you could do, though, Dan, is you'll see here once you get under theme, you've got, depending on which theme you choose, you have the ability to control the components. So in this case, for Smart Tile, we have high through low. And so for each level of the theme, you could actually control the size here. So it's not as dynamic as the theme itself, but you certainly can control the point size for each level of the theme. Did you follow that, Dan? Got it. Cool. Thank you. Great question. Took me a second to remember how to do that. Okay, well, if not, I want to make sure we have enough time for Connor to run through the predictive components of today's session. So feel free to continue to ask questions and we can answer them in the chat or take them offline, and appreciate your attention.
Cool. And just a time check, we have till the end of the hour, correct?
I believe it's till 11:10, but you don't need to use the full time if you do not wish to.
Okay, cool. No, I just want to make sure to keep my pace. Let me go ahead and share my screen in a second here. All right. And I do have some slides to start off with, so I believe this is the right monitor. There we go. All right, so today we're really going to go over kind of an intro to get you started on how to use the predictive tools in Alteryx. One caveat with the predictive tools is if you just downloaded like an Alteryx trial or just the standard version of Alteryx, it does require another download. So we will talk about how to get that in. But, kind of things we're going to cover is talking about the different types of models, classification, continuous, time series, and then there's some others in between that. And it looks like, based off of the poll, most people said forecasting is something they've seen before. Today, we're going to continue with the data that we've been working with, the student application data, to do more of a continuous model, but we'll touch on all those topics. And then R and Python, it looks like most people haven't used R or Python before, and no need to worry. We're not using that directly in Alteryx. There's no coding, but if you did want to venture into those languages in the future, you can incorporate it. And then the last question I wanted to address, I think, actually, yeah, that's it. So let's get into it. Next here, just agenda, again, going through downloading those predictive tools, reviewing the data science life cycle, and really where the key parts are that you're going to spend in Alteryx. And then one of those key parts is data investigation, is where you're going to spend most of your time, and then we'll move on to the types of models you can build out, and then evaluating those models and just talking about some further resources to dive a bit deeper into predictive. So if you haven't downloaded the Alteryx predictive tools before, you would know so by being an Alteryx designer. And when you click on this predictive tool category, you would probably only see this boosted model and the score tool over here. And if that's all you see, what you'll need to go ahead and do is go to this link here, help.alteryx.com, the download. This takes you through a guide of bringing in the predictive tools. It's through our help documentation. Otherwise, you can go to the site that you downloaded Alteryx from, and there will be a separate download underneath your Alteryx designer that says download our packages for predictive tools. So that's what you'll want to get in. It's a brief download, but it brings in those extra components. We just don't package it all together in case you don't want to use predictive. And then further, there's a model comparison tool that I'll be using today. That's available at gallery.alteryx.com. And real briefly, I'll show you how to get to that. So let me go ahead, pull up a browser here. So if you go to gallery.alteryx.com. This is basically the public server for Alteryx, where if people just want to brag about a workflow to the public, they post it out here. But additionally, if you go to this districts tab, it has a whole bunch of categories on whether you could download maybe a new tool somebody created. In this case, that's one of them. So you would want to go to the Alteryx product district here, or the predictive district. I think it's in the predictive district. And you would want to go ahead and find this model comparison tool. And by downloading that, it'll install, and you can get that right inside your Alteryx designer, inside that predictive category. So that's the additional function we're going to bring in. As you can see, if you want to explore more predictive models, there's a lot here that the community is building out around predictive grouping and several other things. So really valuable site to find more. But with that said, let's go back to our presentation here. And the next thing that we're going to talk about is the data science lifecycle. So most of or a couple of the things we've already conquered already, but kind of value of this is in steps 3 and 4 of this data preparation and data exploration. That's where we're going to spend a bit of time today through the data investigation blocks in Alteryx. But as we see step 1 and 2, the beauty of Alteryx and what we kind of talked about yesterday during the intro sessions is, what's the business understanding? That's something we have to come to before we even start building a workflow in Alteryx. And then data acquisition, finding all those different data sets and working through the data preparation in step 3 to go ahead and get to one nice clean data set that doesn't have null values and has columns that we can actually predict things off of. So whether that's taking different classifications and making those 1, 2, 3 as numbers, or maybe just cleaning them up so we make sure we have a finite amount of classifications we want to examine. Those would be things we do with the data prep tools in Alteryx, such as like a formula tool. And then moving on to step 4, this data exploration engineering, we're going to talk about that through the data investigation tools, but it may, come to the point where we do some exploring and then realize we have to do more data prep. And then we repeat 3 and 4 a couple of different times until we get to the point where we're ready to build a predictive model and then interpret that model and deploy it out to the masses, which may be through Alteryx Server. So with that being said, what we're going to go ahead and do next is talk about the different types of models that we can use. So this map is pretty nice in that it helps, go through that data science life cycle and break down maybe how you would get to a model. So business problem, what are we trying to do? Are we trying to predict a yes or no question? Is it an outcome that we're trying to predict? Or are we just trying to do more analysis? And if we're predicting something, we're going to go down this data rich, data poor, and really figure out kind of where to start. But if it's data analysis, we have those tactics in Alteryx already. We've done, geospatial. We've done the aggregation through things like the transform tools or summarization, and then descriptive analytics, maybe just putting things through those reports. So once we get to that, today we're in that predict outcome. Our business problem is that we want to go ahead and predict whether a student's going to be admitted to the school or not based off of some test scores. And right now we're currently in the data rich stage because we do have a lot of test scores that we've examined across the data set. Matt used yesterday and today, same data set. And if it was data poor, maybe we would go to something like A/B testing to test out different scenarios to find which data we actually want to use. And that's an area of data investigation where we'll determine this break. But from there, going down into numeric and classification, you can really see the split between models that you want to build out. So today, what we're going to be using is a logistic regression and a boosted model, which is actually a compilation of several decision trees. And we're going to compare those through this classification stage. Notice there's the binary, non-binary, but in this case, the boosted can still predict a binary outcome. And it kind of works for both scenarios. But over to the left, we have numeric. So if we were trying to predict maybe a test score of a student based off of some other data, that may be the way we want to go. Or for instance, not like forecasting a seasonal time number, but forecasting a number off of other metrics, we would want to go ahead and use that. And again, you'll see some of these models replicated for both, like boosted model, you could use it there, or the forest model, and they work in both situations, classification or numeric. But this kind of tree helps you decide what range you should look at. And then if it is time-based here, you'll see those are completely different models, which is ARIMA and ETS, which is separated into its own tool category in Alteryx called time series. In 1 second, I lost my chat window. So Matt, do you mind letting me know if there's anything in the chat? There we go. Okay, cool.
No, you're good. Yep.
So going through this, what we're going to go ahead and talk about first is the most common profiling tool, which is the browse tool. We saw it in Matt's spatial demonstration to see maps, but to overview your data and really understand, is this data of quality? You want to use this browse tool to go ahead and see the frequency of maybe different categories across a column of data, the size or the amount of null values that are in that column of data to recognize what are the first data prep steps that I need to go down, or off the bat, do I have enough categories in this data set to predict something that is reflected in this historical data. So really helpful to assess, some of those baseline statistics. Even if it's a numeric field, it's going to tell you like standard deviation and average of the values. And from there, you can get a good assessment of maybe what columns you want to include in your prediction or to influence your prediction. And if it's not as clear from there, we can dive into some additional resources as well, which is found in the data investigation category. And one of those data investigation tools is a field summary. We'll go over that today. What that does is basically provide some of the values from the browse tool, but in a more collected view. It has 3 outputs from it. It has descriptive statistics, which you see at the top, which actually outputs these statistics into the workflow itself. So you can use those through a formula tool to maybe see, percent missing. If you were to feed in a new data set, let's look at this percent missing column and let's filter out anything that's, 80% or higher. As well as unique values. You may want to look at that. If it has one unique value, then that's kind of a piece of our data that's not going to provide any influence on a new prediction. So using that output as an advantage in your workflow can help you build in the steps or build in your decision steps to go ahead and clean up the data and find what you want in an automated way. or you could look at these diagnostic reports. So you have a static report. This is data showing you same things, it's just more in a report format for each column of your data. And then the interactive visualization, we'll actually see that in action today. This is going to show you a plot of all the values in each column, and it'll help you understand which column has a nice bell curve to it in a nice range of values, so that you can understand whether that's meaningful to use in a prediction or not. Okay, so next data investigation tool that I wanted to talk about is the frequency table. So this helps you understand, just as it says, the frequency of values across the data set, just in a more aggregated view. So you could go ahead and look at cumulative percent, cumulative frequency, or just the percent of frequency of each category throughout a data set and how often that occurs. Pretty straightforward there, but just gives you a nice table to view all those numbers for each given field. And then by far my favorite, the association analysis tool. This is really used to find the correlation between different fields in your data and help you understand what has maybe multicollinearity. So what fields have such tight influence to one another that they may be things we could understand. That maybe one example I give is like if you were using basketball statistics and you had 3 points made and 3 points missed, and then you had another column that said 3-point percentage. Well, 3-point percentage is basically reporting the same thing as those first two columns. So you kind of have multicollinearity there, where all of those are kind of leading towards the same outcome. So you may not want to include all of them as something that's significant to predict what the final score of the game is. You would just choose maybe one of those based off of the examination in the scatter plots to the right. So what you'll see in the demo today is we can click on these different cells. It'll display a different scatter plot for, in this case, litter size and greatest or gestation month. And it's going to put those out so you can understand what linear trends there are. In this one, there's not too much of a linear trend. And some more deeper ways to look into that is values closest to 0 are more muted. So if you like it could be blue or red, but more pale colors are the muted ones that don't have as far of a relationship. And then those more solid colors are things that have a closer relationship to -1 or 1, which will hold some influence in the prediction you want to make. So these are key things we'll look at to understand what data is meaningful further than just that browse tool. And you can really use any one of these data investigation tools you want. There's several more I haven't covered today, but it just kind of depends on what model you're building out and how you want to look at that data so that you can perform steps 3 and 4 of that data lifecycle to prepare, analyze, and then finally get to the model you want through the several iterations you'll do. Okay. So again, this is kind of a word busy slide, but I did want to show the imputation and the data cleansing tool. So when it comes to missing values in your data, the data cleansing tool has a really nice feature that says if the value is null, replace it with a 0. And that may be something you want to go ahead and do as a preparatory step once you realize there is zeros all over, or I'm sorry, there's no values all over one column of my data. You could quickly plug in that data cleansing tool and switch those nulls to 0. However, that may not serve you the best statistical outcomes. You may actually want to go ahead and look at your data set and say, instead of imputing a 0, let me figure out what has more value. Is that a mean? Is that the median? And how can I more statistically represent this historical data set so that it can have the best influence on building a predictive model? So in that case, you would use this imputation tool, which allows you to go ahead and select a certain value and replace it with another value across the data set. So maybe you replace that with zeros and then you put in the imputation and replace each 0 with a mean or median. But this is a really key step for cleaning up your data so that it's ready to be using a predictive model. And typically, this is something you may come back to the imputation after you do some data investigation. You may say, okay, this is skewing my data set. Let me go back, impute a different value for those blank spaces, and then see if that adjusts kind of the skew of my data in maybe that field summary tool. Cool. So from that case, it's time to build a model. So the way that this is going to look in Alteryx is first you're going to sample a model down below. So there's a prep tool in Alteryx that allows you to split your data set into different percentages. So 50-50 split, or maybe a little bit different than that. Basically, this create samples tool gives you 3 different outcomes. The E is going to be the evaluation that you'll plug into your models to go ahead and train them. The V will be your validation that you will plug into your model comparison to go ahead and take the models you've trained and then feed it some new data and then understand how it's performed. And then the last one, H, is historical data. So if you just do a weird percentage like 20-20 on estimation and 20 on validation, the historical will push out the rest of the records there. So that's how that's going to work from the start. But these brown tools here, you see a decision tree and the logistic regression. We're basically going to do a similar configuration where we take that estimation, plug them in, and then we choose what we want to predict, what values we want to predict off of, and then we'll go ahead and feed the results into this model comparison. And we'll show you some tips and tricks to remove a lot of these lines if they get a little too busy for you. So the next step here is when we go to that data investigation, we've built a model, we've done data investigation, we're analyzing the results of each one of these models. There's some key things that we want to eliminate is the multi-collinearity, which I talked about in the beginning. So things kind of predicting towards the same trend, basically kind of like duplicate columns of data when it comes to the significance and association. And then the predicting variables that fail to predict the target variable. This is something that we're going to see as a result of the models we build. So we'll go ahead and look at some of the reports that are digested in the end, and we can see what significance they had and p-values of it to go ahead and figure out, okay, this is something that's more significant towards my prediction, and then the other values maybe I can drop. And these are just things you're going to evaluate as you iterate through your models and figure out which one's best for you. All right, so last thing here, the model comparison output. This model comparison is that last tool we're going to sync our validation data to in our models, our different models we create. What this is going to do is give an aggregated report that basically shows the accuracy of true values and accuracy of false values, as well as overall accuracy of each model itself. And then it's going to give us a confusion matrix and some other charts you don't see on this screen to go ahead and help us digest each model. So how a confusion matrix works here, if you look at this decision tree, really what this predicted 0 means is predicted no, and then predicted 1 would be predicted true. So what this means is if it's predicted, no here, what was the historical value and was this actually accurate is what's being reported in this first cell. And then if we look at predicted no, but it was actually true, we had 10 values we missed there, and vice versa on the other side. So this is a really clear depiction, obvious to the eye, to understand how well it is performing, but there's other calculations that go into kind of building out that accuracy from these tables that help you understand an overall number for your model. So this I'll touch on in the end, but or I guess I could touch on it now. So as you go through the community, there is a lot of growing content in the predictive and the data science side on there. So always go and check out the the learning pass in the Academy. So if you go to the Academy on Community, there's going to be Learning Paths. There's one called Data Science and one called Intelligence Suite. These are the two ways you can do predictive analytics in Alteryx, and it's a really nice guided tutorial that links you to knowledge-based articles and interactive lessons on how you can continue this predictive journey. And then Intelligence Suite is something I'll talk about at the end, but it's a new part of the Alteryx platform that you can add in that helps you make some of these decisions for you. And this is really exciting new piece of the platform. I'll briefly go over it at the end. And then the other parts here are just kind of things on specific time series or the classification models we're going to go over today. All right. And thank you, Matt, for putting that in the chat. So let's dive into it. Let's talk about what we're going to predict today. So if you were following along with the other sessions, basically what I did is created an input file of the same data we were using after like the formula tool we used in the first workflow yesterday. And this is going to include all data that has an individual key for the student. It has zip codes and spatial information we used in Matt's session there. And then a field that tells us whether somebody was admitted or denied, and then a more descriptive field that we're actually going to use that has admit status. And these are just different ways you may display that field just to show, in a formula, maybe you're taking this admit status and it has a third class. You may transform that to 1, 2, and 3 to see it a little bit more clearly in a predictive model. But regardless, this is the binary field we're going to predict off of, admit or denied. And then going over to the right, we have college variables that we could potentially include, but today's focus is really going to stay on the numeric scores we have for test scores. So we have high school GPA, class rank, we have the school size, ACT scores across the board, SAT scores across the board, and then the term that they came in. But we're going to really focus on these numeric ones today. And the first part of this step is to go ahead and understand how clean is this data? Do we have any null values? So if you remember from the presentation, I guess I'll ask a question here. What's the first tool you would think of to understand null values? If you want to put that in the chat. Yes, awesome. Thank you, Dan. So the browse tool is the best place to start by far. And the first tool you will always see in your favorites category unless you change that up. So just as you can see them, the null values actually in the results window here, you can hover over and see 100% okay. It's going to tell you that's clean data, meaning it has a consistent size and values across the board with no null spaces. And then the browse tool, we will drag in at any point we want in the workflow to either see a report that's coming out of a predictive tool or just a report about our data. So you'll see by far that's the most popular tool used with these predictive options. And when we click on it, you'll see to the left that we have each profile and the top classes in each column. So if we're looking across years, we're really focused on 2009 through 2012. And then one thing that I do want to look at here is maybe what's my population on the admit status. So we can see denied here, I have 738 records and admit 467. This is a decent balance between records, but it could be something in my second iteration of building a model that I sample a little bit differently. And then undersample the denied scores so that I have an even representation across each one of these. So those are kind of decisions you want to keep in mind. And when we come to those sample tools, those are mainly going to be found in the preparation category. So you'll see that the most classic sample tool used is this sample here. And if I drag that in and we took a peek at the configuration, you're going to see this is really in one stream of data. You can sample it to one specific portion and you don't really get multiple outputs. So you could do, first N% of rows, or you could do, skip every 5 rows, etc. This is the most basic sample you would want to do, but the one we want to focus on today is this create samples because it splits different streams for us to use across the predictive process. And in this case, over to the left, I designed estimation to be 50% of my data and validation to be 50, and those are going to come out the E and the V here. And then further than that, if I was doing that undersampling or oversampling to equal out the status, you could use something like oversample to go ahead and say, hey, I need a exact representation or even amount of records between admit and denied. So that's a valuable tool there. And with that being done, what we're first going to start off with is this key E estimation, and we're going to plug that into our predictive models. But the first thing that we want to do is some further data investigation below. So if we look at the investigation category, you'll see the field summary, which we're using here, came from this category in the association analysis. There's several other tools to be used like heat plots, histograms, etc. And one of the really cool things about these visualizations is they're all built on the R code that comes from R or Python. So if there's some type of data science visualization you want to build, or just a statistical summarization that comes from a coding language, if you've used them before, you can always put that piece of code and create your own tool in Alteryx, and that's how these are actually built. So it allows for a lot of further customization if you're really into the data science field. But today we're going to keep it pretty basic on the field summary. So when you connect data into the field summary, it first asks you to go ahead and select all the fields you want to analyze. Now, I had mentioned earlier that we really want to focus on the ACT and SAT scores as well as high school GPA, so everything numeric. And what we're going to see is just a summarization of each one of those fields. You can do some sampling in this field summary to understand, like maybe as you do your second iteration, you would click the sample field and say, give me a random number of records or a random percentage of records to go ahead and understand maybe what percentage is best to reflect the range of data that you want to use in your predictive model. And then once you find that, you can put that into the sample tool. So the 3 outputs of this, the first one, the O output, this is the data you could continue to use in a workflow. So if there's % missing, again, another way to understand those null values, you could plug this in, filter those out right away, and make a dynamic workflow to do that. You'll see unique values, the average across the fields, min, maxes, and median. So pretty straightforward here. And then if you want to see a visual portion of that, what this is going to do to the left is display some of the scatter plots of all the scores. So these are simple scatter plots, and if you ever want to blow this window up to see it a little bit better, a little trick here is click on the plus icon with a little box around it, and you can open in a new window and drag that onto the screen. So this is pretty helpful with the predictive tools, as there's sometimes a lot going on in these reports. But this is same numeric data there, but we just get the scatter plot. And then the last one, my favorite of the field summary tool, is the interactive report. So what the interactive report does is it takes all your fields so you can see it in one view here and you can interact with them. And this allows you to understand kind of that bell curve and the range of values across each column a little bit more visually. So some things that stick out to me here are like this high school rank is highly skewed to the left. And maybe that's something I don't want to include in my prediction later on, or maybe it has enough meaning as I do a little bit more investigation that I do want to include it. Everything else in here has a nice range of values so that I know it can assess maybe for future data coming in a larger range, and my model won't be biased to maybe one side of the spectrum. So these are all things you may evaluate throughout. But the association analysis, that's the next tool here. This one really helps you understand that collinearity. So basically, if you click on the association analysis, if you have a binary field that you want to predict, in this case, whether students can be admitted or not, you can select that admit status field and then put the positive class of what you want to predict. So in this case, a student's being admitted, and we can see that by checking our data. And then down below, we'll select all the fields we're interested in again and choose the measure of association. I'm not going to dive too deep into these. The default really is Pearson correlation, but if you want to look at some different correlations, you can dive into those, and the help documentation is a really good way to learn more about them. And so basically what comes out of this is the report. Again, that's just kind of the descriptive report. So if we stretch this out, it's going to show us in numbers what each column has association to the other. So math to high school GPA has a 0.5 association, which is okay, but we can see SAT writing to others have a stronger correlation. And really what we want to do is compare which has the best correlation to what we're trying to predict, which would be this admit status number in this case. So the better way to view this is the interactive chart. And the interactive chart shows this in a kind of heat map here, so we can see the duller colors to the top. But if we want to look at these hotspots, we could see SAT read to writing, similar type of test. They have a very strong correlation throughout. So I may only want to choose one of these. If I were to look a little back to SAT science and high school GPA, we can see boards or numbers are all across the board. So high school GPA doesn't have a strong reflection of that science score on the test. So interesting things we'll find out there, but as you go through, you may find things that have more correlation or less. Typically between like 0.4 and 0.6 are good fields to look at, but again, it all kind of depends on your data and what you're trying to analyze. This data set, since it's human, based information, is going to have a lot more variance than maybe some other elements you predict. So it may require more iterations as you train that model. All right, so that's the association analysis and understanding correlation. Once you go through this, you'll make those decisions, see those key fields that you want to try out, and really just plug them into a model up above. So the two models we're going to use is logistic and a boosted model. And these are both classification, and we can find them from the predictive area up top. So as you read each snippet about these, you can click on it, look at it, see a general description that's going to tell you whether that's classification or continuous, and it tends to give you a nice little use case about it. But for deep diving in this, I really recommend that data science learning path or the predictive learning interactive lessons on community, as well as like that chart that I showed you at the beginning, helps you really filter out which one of these to potentially use. And today we're focusing more on this left side of the spectrum, which is going to have the classification of the boosted model, which is actually kind of built off of a single decision tree. And what these do is basically create trees to split, like, is this a duck or a dog? Maybe that's a prediction we want to make. Maybe that first question we would ask, does it have 4 legs or does it have 2 legs? And it creates a tree there. And then the next question will be asked, creates a tree, and it builds these to go ahead and figure out kind of what tree is best. And then that will be used to help promote the prediction. So you could start with one single decision tree here, or you could do several trees that you set a hard value on how many trees it goes through to find the best through a forest model, or the boosted model is kind of a good collection of all of that iterates until it finds sort of the best tree at a high level description there. So really cool ways to just kind of choose, maybe start with a decision tree and then progress to a more advanced one. And then one of the most common regressions for binary classification or true or false values is the logistic regression. So those are the two things we're going to focus on today. There's a myriad of different tools that you could use here, but let's go ahead and put these to work. So to put this to work, the logistic regression here, if we plug that in, really we're just going to take from the estimation set of our data and draw that right into that logistic regression. What that's going to do is promote the configuration to the left. That just allows us to choose what we want to predict, which is the emit status, and then choose the fields that you want to select, as well as you will name the model. And naming this a good, measure of this is actually a logistic regression instead of Connor's regression is probably a better idea, because it's going to help in this model comparison to know where that came from. So just a tip there, but as you go through this is the standard setup people do. Just pick what you want to predict, select the fields you're interested in, and then we'll train, look at the report, go back to data investigation, and reiterate until we find the best model we want to use. If you are, again, more have a data science background, there are additional parameters you can set here for cross-validation and changing the plots that you use, or maybe the model type that you want to use behind this logistic regression. So there is a lot of customization you can build into this. And it's, depending on, those iterations you go through with building the model and what you see fit. So that's done with both the logistic and the boosted model. The boosted model, again, is going to look very similar. You choose emit status in the fields you want to predict with. And then you could also do sampling weights in this as well, and a marginal effects plot to go ahead and add some additional parameters, but these are optional. Again, model customization, if you want to do that cross-validation and really adjust the numbers behind this algorithm, you can. But in this case, we're going to go with the defaults. So you set that up, and now we're curious on, all right, what did the model actually predict? So what we'll go ahead and do is always put the browse tools behind the I and the R output, or maybe it's just the R depending on the model. But what these do are supply similar reports as we saw in the data investigation tools, but this is going to give it to us once we've performed the model and understand kind of the outcome. And then the O output here, you'll see is always just a one-liner that says the model name, you named it, and then it has this object in bytes. What that actually is the R code that was built behind this model that's stored so we can use it in the scoring algorithm or the model comparison down the line. So that's extremely important, but you don't have to put a browse behind it because nothing's going to pop up for you. So going into the descriptive report here of the logistic regression, some key things we'll want to look at is that first it tells us the algorithm it used to build this out. So if you wanted to take our values, plug those all in and build out that calculation by hand, you technically could. Then it tells you the deviance in between the values and kind of the segments of your data to understand, is that good deviance you want to look off of. Typically, people try to stay in that -2 to 2 range, which this somewhat reflects based off our historical data. And we can see the majority is within that range between the first quarter and the third quarter of the data, or quartile, excuse me. And then going down further, this is really the part we need to take away here. So this gives us the coefficient that is used in that formula. So again, if you want to plug that in, the standard error on each field, and then the key p-value here. And the p-value helps us understand how significant that field is to predicting some type of outcome. So we can see high school GPA here has 3 stars, and that the p-value is quite a bit lower, which means it has a little bit more predictive significance, because what we're trying to, or what this is doing is telling us how far away this value is from predicting the null hypothesis. So basically saying these are values that can predict something against the default, which could be, in a probably poor example, whether every student's going to be admitted. So this would help us determine what significance that field has to add a little bit more variation into the model and make it a little bit more accurate. So the high school GPA here, we see 3 stars at, and this breaks out the scale here. So that's one of the most significant. And then we have SAT read and writing are pretty key. And then the last scale of this is a period for a 0.1 correlation under SAT math. So we can see that this favors the SAT scores quite a bit. And actually, going through college, that seems to be the biggest factor, as SAT is the most common test that students probably take, at least when I went to school. And then the boosted model down below, this is same thing. What we're going to see as an output here is similar type report, but this actually gives you a graphic to show you the variable importance. So we'll see high school GPA, SATs are still at the top, but this interpreted a little bit differently, like to take in some of the ACT numbers before the SAT. So just a difference in models we'll build, and when we compare them together, we'll see really what the differences are. So good outputs there. One thing I skipped over is the logistic regression does have an interactive output to view that data we just talked about in the report. And this does show things like the accuracy and precision. If you shrink this window, excuse me. All right, so it has accuracy here, recall, and then that decision tree you want to look at for true predictive values versus false predictive values. So really great plots to go ahead and dive through. But once you have all that done, we link it all together and compare everything. So looks like we have a question there. Is there a page which shows how to add custom tools like model comparison? Yes, I'll go ahead and forward you some instructions to that super team. If we don't have a page on it, I have to look if there's a specific write-up, but I will follow up with you on that. And another thing you can use in the meantime is the lift chart is a same model comparison. It's not the same, but it does provide plots for model comparison. So you can use that right away, and the input anchors work just as this model comparison. You have data and then the models you would read in. So when you go ahead and tie this all together, the first thing that you'll need to do is take the output of the logistic regression and the output of the boosted model, which are these encoded R bytes, and then go ahead and stack them together in a union tool so we have all the models in one data stream. And once you do that, you can feed it into the model comparison tool, which the M stands for model and the D stands for data. Now, one thing I did want to highlight as a trick here is when I click on this D anchor, you'll see that this faint line goes through. So by clicking on the anchor of a connection, you can say make incoming connection wired or wireless. This is a really nice feature with the predictive models, as you may have several tools. And to kind of remove those lines from crossing over tools, you can always right click on the connection or the anchor it's being fed into and say make that a wireless connection so it disappears. But you'll see this little Wi-Fi antenna off the side if I zoom in there to show that there is something going into it. So with that being done here, what we're doing is taking the validation data, so the V, that other 50% we split from the sample, and pushing that into the model comparison. And in the model comparison, it doesn't require really a configuration. We could put the target positive class, but we really care about the outputs of it. So this one here basically has the accuracy outputted as data. So again, if you wanted to create your own custom filter on this to iterate through some models, maybe you train 4 models and then put the best one into production, you could use your filter tools from the beginning to go ahead and find the best accuracy score or assess these in whatever calculation you need to go ahead and deem that best model. And as we look at this, we can see off the bat, logistic regression is just barely more accurate, but when we dive into the specific scores, we can see it's less accurate on the, or it is more accurate on the omit. And if we look at the boosted model, it's more accurate on the denied. So just by looking at these, maybe testing out more variables, we could, change some of the numbers behind the algorithm and see which one's a little bit better. But in this case, they're performing quite similar. So to dive into those reports a little bit more, we'll look at our second report. which is just going to show a log of each record admitted or denied versus the actual. So we can see Logistic got, or both of these got this one wrong by chance. And this is basically the data behind that confusion matrix we talked about. That's going to show to us a little bit more descriptive the status of each prediction. So if we want to look at those confusion matrices, the best report here is coming out of the R output for the model comparison. And if we stretch this out to the right, at the top, we compare. Again, same numbers we were looking at. Accuracy is going to tell us that overall accuracy. AUC stands for area under the curve, which is, it's basically going to tell us kind of true positive versus false positive to go ahead and analyze. We want a higher number there to assess more scores that we predicted correct. And then the accuracy admit is just breaking down that accuracy number in admit and denied. So as you go through this, we have the boosted model. That confusion matrix, again, looks like we got 139 right for the admit and 314 right for the denied, but we missed around 140-ish records, 150-ish records there. And then on the logistic regression, similar, but we have a loss on that actual denied here that we predicted some wrong. So overall, maybe we go with the boosted model there. Just up to you what kind of means a little bit more there. So going into this, you have some of those plots I was talking about. I'm not going to go into every single one of them. Help documentation is really key on this, but basically showing the lift curve. You have a gain chart that's going to tell you true positive versus rate of positive, precision and recall, and then the true positive versus false positive in this ROC curve here. So one key thing on this one is we kind of want to look for that line that has that higher arch. These are pretty close, but this logistic at the top kind of has a better rate. So maybe you go with that. With these two models, it's kind of up in the air and maybe has some retraining you want to think about. So this just shows the kind of steps you may evaluate as you go and build out models, and how you may go back, change the sample of the data to see what change that has, or change the predictor variables to see how these charts change. And that'll help you understand for larger sets of data or newer sets of data that you're going to feed in, which model can encompass all those factors better and has less bias to the data set that you originally trained this on. So that's how the model comparison works. But the last and by far most meaningful step once you build out a model is to make that decision on what model do I want to use. And then you take the model and plug it into this score tool, which really doesn't have a configuration. All it does is takes the model, takes your new stream of data. In this case is my validation set feeding in, and the model that I want to use, which I chose boosted, and then clicking on the output. What it gives you is two new columns of data, which is the percentage admit and the percentage denied score for each student. And this is where you can go ahead and filter out maybe a sample of this to represent the population, or, you know, put back in those descriptive reports to aggregate how many students you're thinking to admit, and then report that out in a nice visual report through maybe spatial analytics or just descriptive analytics. So that is predictive, the fastest crash course I could probably give on it. There's a lot of topics to continue discussing on here, but again, if you go out to community, the areas I was referencing is, if you go to Academy here, come on. And in the Academy, if you go to these learning paths, you're going to see the two different ways that you can learn how to do predictive. Either the way that I talked about today through the data science path, which is building out that whole construct on your own and doing your own validation. That's more of the data science side people want to look into. Or you can look at a quick tutorial or this learning path on the Intelligence Suite product we offer that includes the assisted modeling, which basically helps you make those decisions throughout to build the best model and put some machine learning in the background to go ahead and help you understand maybe if you have blank values, should you replace it with an average or a median, or if I'm going to select which values to or columns to predict emit status with, which one of those have the best significance, and it helps you and guides you with some of those decisions you want to make. So really cool add-on there, and if you want to dive into it, that's a really good place to learn about it. But I think we have 5 minutes left, so I'll keep that for questions. I see one came, oh, that's from Matt. All right, so if there's any questions over spatial or predictive today, I know there's a lot we went over, feel free to ask or put in the chat, and Matt and I are happy to help.
Awesome, thank you so much, Matt and Connor. But yeah, like you said, we'll remain here for questions for the next few minutes. So
the other call out I guess I would make is if you are interested in additional spatial or predictive learning, we've called out a couple of community-based options, but certainly reach out to your internal analytics team, and we can certainly set up some more advanced training, some more deep dive training into these capabilities, as well as your use case.